Hello, and welcome to today's lesson on scatterplots. So in the past couple slides, you've been introduced to scatterplots, and scatterplots are used to show the relationship between two variables, the variables that are on the x and y axis. And for these graphs, they're called scatterplots because all the points are scattered. So when we're taking a look at scatterplots, we are looking for a trend in the data. So is there no trend? Sometimes there's no trend. Is there what we call a positive correlation or a negative correlation? So a positive correlation is going to be when your data values increase from left to right when you're looking at the graph. And your negative correlation is going to be when your data values decrease from left to right when you're looking at the graph. So let's take a look at these first couple examples. It says determine if each scatter plot has a positive correlation, a negative correlation, or no correlation. So we're looking for a pattern, a trend in the data. So for this first graph, as my x values increase, my y values are decreasing. So my y values are going down when I look at the graph from left to right. So this would be a negative correlation. Okay. For my second scatter plot here in this graph, as my x values increase, my y values are also increasing. So as I look at the graph from left to right, my data points are going up. So this would be a positive correlation. Now, when you have a negative correlation or a positive correlation, you can draw what we call a line of best fit, and you may have heard it called a trend line in the past. And this is a line that we're going to draw that we feel best represents the data values. So we're going to draw this line because it allows us to make predictions for future data values. Now, when you're drawing a line of best fit or a trend line, there are some things you want to consider. Obviously, because it's a scatter plot, not all your data points are going to line up nicely. So when you're drawing the line of best fit, your goal is to try to get as many data values as you can on the line, but you're not going to be able to get all of them. For the points that aren't on the line, you do want to try to have an equal amount of points above the line and below the line if you can. Okay, so those are some things you need to keep in mind. So let's take a look at our first example where we need to draw a line of best fit, come up with the equation for the line, and then use that equation to make some predictions. Okay, so a teacher made the following graph showing the average number of hours her students spend watching television per day versus their grade point average or GPA. So here's our graph, and you can see as I look at this graph, my data values are decreasing from left to right, so this is going to have a negative correlation. So when I draw my trend line, it's going to have a negative slope. So positive correlation, your trend line is going to have a positive slope. It's going to go up from left to right. But for a negative correlation, your trend line or your line of best fit is going to have a negative slope. It's going to go down from left to right. Now, drawing a line of best fit is not an exact science. So you want to try to do your best to try to get as many data values on the line. For those that aren't on the line, you want them to be as close to the line as possible. And if you can, try to get an equal number of data values above and below the line. So when I take a look at this graph here, and if you were doing this by hand, you would want to take a ruler and just try to line up the data values, and you might have to move it until you feel like you found a trend line that's going to work. Because we're going to be doing these virtually, most of the time the trend line is going to be drawn for you, so you'll just have to come up with the equation. But it is kind of a trial and error process, so if you draw something you don't think it looks right, just erase and try again. So for this graph here, that is where I would draw my trend line. So you want to try to get it to go through the center of the data, which I've done. I have 2 points that are on the line. For the points that aren't on the line, they're pretty close to the line, and I have 2 points below the line and 2 points above the line. So you got to try to just do your best here. Now, it says draw and write an equation for the line of best fit. So once you have your line drawn, or if it's already drawn for you, what you want to do is you need to identify 2 points that are on the line. So I circled these 2 points that are on the line, and I'm going to write out their ordered pairs. So I have 0, 4.0 or 4. And then my second point is 4. So it's this point here. So it's 4, 3.0. Okay, so those are my 2 points. These are really important to identify because they allow us to find the slope of the line. So remember your formula for slope. And this is given to you in the Google Slides presentation if you've forgotten it. y2 minus y1 divided by x2 minus x1. So my 2 points that I'm using, and I'm just going to do 0, 4 instead of 4.0 just because it'll make things easier when I'm showing my work. And then I have my 4, 3. Okay, so remember, when you're using this formula, it's helpful to label your points. Your first point, you're going to use the number 1, so x1, y1. Your second point, you're going to use the number 2, so your second x and your second y, so your x2, y2. Okay, and then I'm going to plug those values into my slope formula to find the slope. So I'm going to do y2 minus y1 all over x2 minus x1. So I have 3 minus 4 all over, so y2 minus y1, and then x2 minus x1. So I get negative 1/4. So there's my slope. Now, when we're going to write the equation, we now have the slope of the line, but I need to write the actual equation. So what I'm going to do, and your steps are over here, it says substitute the slope in one of the points into point slope form. So here's my slope. I have 2 points to pick from. It does not matter which point you use. You want to pick one of those and substitute into your point slope form. So here's your point slope form. Here's me substituting. I'm going to take my slope and I'm going to use this point, this 0, 4. So this is the point I've chosen. You can use the second point if you want. It does not matter. But because that first point is already labeled x1, y1, I just think it makes it a little bit easier to substitute those in. So I'm substituting in 4 for y1, and I'm going to substitute in 0 for x1, and I'm also going to substitute in my slope for m. Okay, now once you get your equation in point slope form, you do have to go ahead and convert it over to slope intercept. So remember, slope intercept form is y equals mx plus b, and y needs to be by itself. So to go from point slope form to slope intercept, you need to solve this equation for y. So I'm going to distribute my fraction. So I get negative 1/4 x plus 0, because negative 1/4 times 0 is 0. I'm going to add 4. Trying to get my y by itself. I get y equals negative 1/4 x plus 4. Now notice, and here's a good way to check your work, in the equation my y-intercept is 4. Guess where my graph crosses the y-axis at? 4. So that's also the y-intercept you see on the graph here. Now the reason why it's helpful to come up with an equation for the line of best fit, or the trend line, is because it allows you to make predictions. So look at your next question here. Predict the approximate GPA of a student who watches television for 9 hours. So notice, if I want to go ahead and make a prediction for 9 hours, sure, I could look at my graph and try to eyeball it and make a prediction, but this is going to give me an exact answer. So I'm going to take my equation I just came up with, and I want to know what the GPA will be for a student who watches 9 hours of TV. Okay, so if you look at your graph, X was your hours of TV, Y was your GPA. So I'm looking at 9 hours, so that means X has to be 9. So I'm going to go ahead, plug in 9 for my X. Okay, and all you need to do now is evaluate to figure out what Y is. So I'm going to take negative 1/4 times 9, and I'm going to add 4. And I get 1.75, which if you look on your graph, at 9 hours, it looks like the line was hitting a little bit below a GPA of 2.0, so 1.75 makes sense. So For a student who watches TV for 9 hours, his or her GPA would be around, and this is an approximation, so it's not an exact answer, just because we're making a prediction. So we would estimate it's somewhere around 1.75.